In this session, we are going to talk about functions and we are going to understand what are functions, why are they needed, and how to use functions. We are going to see the basic usage of functions. We are not going to go into topics like default arguments and keyword arguments and variable length arguments. We are going to talk about them later. So let's start. Let's start with a very small example with a code piece to understand why do we need functions in the first place. So we'll start by writing a simple program. Let's say I want to write a program to input a number and an exponent and print the number raised to the power the exponent. Let's say I want to do something like this. To do this, let's say I have a variable, let's call it b. I'll denote it for base equal to input, enter the base. Let's convert this to end. And then let's say e equals to e is going to denote the exponent, and we are going to say input, enter the exponent. Basically, we want to denote just to x raised to the power y or b raised to the power e. And to do that, we are going to keep a variable result equals to 1. So the initial value of result is 1. So how do we find exponent or something raised to the power b raised to the power e? The idea is we have to multiply b with itself e times. And since this is a product based solution, so we have to create an initial variable with a value of 1. Normally, if you're going to be working with something like finding sum of something, some values, then you start with 0. But for multiplication, it's always 1 because 1 is a multiplicative identity. Now let's write a for loop for I in, or we don't even need I, for underscore in range. Let's say e. We have to do this operation 10 times. And what do we have to do is res star equals to b. And then we can go and print res. So this should do a job, and if I run this code, let's say base is 3, exponent is 4, and it prints me the answer as 81. That sounds to be, or that seems to be working pretty well. All right, now this kind of code works fine. And actually Python has a simpler way of doing it. We can just say 3 star star 4 and it gives me the result, which is 81. But let's say we are going to do some complex operation, or we are going to define or we are writing some logic to a certain operation, and we write it something like this without using functions, let's say. Now the problem is, if we write something directly like this, we won't be able to reuse it somewhere. All right, and it doesn't seem very clear like what this code does. You'll have to look at the logic and read what it is doing, and probably even try to understand things from comments. Instead, what Python allows you to do, or what programming languages allow you to do, is they allow you to take a piece of code and call it by a name, and that name itself can be descriptive. So in case of this particular code, we are having two variables, one is b and e, and there is another variable which is res. So result is the outcome, and we have two inputs which is b and e. So what we'll do is we'll try to convert this into a function, but let's see some basic definitions of function, or basic syntax of a function. The basic syntax of a function in Python looks like this. So in Python, we have to use the keyword def. Def is a keyword. After that, you have to define your function name, or you have to write your function name. Then you put these brackets. In the bracket, you can put your argument list, or the variables which need to be passed, or the values which need to be passed into the function for it to do its job. Then you can write the code for the function, or the body of the function inside immediately after this thing. And notice one thing, after writing def is a built-in keyword, and then you have the function name, which is something which you can choose. So ideally it should not be a keyword, the function name. And the function name, you should also avoid using the functions which are already provided by Python. So there should be a name which is not already built in thing into Python, and it should not be a keyword. Then you can provide 0 or more values inside the argument list. You can put one variable, two variable, or more than that, depends on your use case. Then finally, remember, you have to put a colon over there. And after that, you have to define or write the code of your function. Before that, you have to put an indentation or one level of indentation to tell Python that this code belongs to this function. Let's see an example. Let's say I define a function def, let's say print underscore my underscore name. This function doesn't need to take any arguments or anything, and it just says print my name. This is a very simple function definition where I'm just saying I want to print my name. And this is, if I run this code right now, it's not going to do anything, because function definitions are just like creating something. We have defined a function, or we have created a name which points to a piece of code or which contains a piece of code. And to use it, I have to actually call or invoke the function. So there are two parts to it. One is definition, which is this part. And there is invocation or calling. This is this part. So once I do this, it starts running my code and it starts printing my name. And I can do or call this function n number of times, as many times as I desire, and it will do the same thing again and again and again. So this is an example of a very basic function. Now let's come to some functions which can take certain arguments. Let's say I want to define this function. Instead of printing my name, I wanted to just print some name, which is being passed to it. And I wanted to print it in this way, like format string my name is, and after that it should print the name. What I want to do is I want to pass a name variable over here. So whoever calls this function from anywhere, whatever value they pass into this function, that will get stored inside this variable name, and that will be accessible inside this function by the name. That might sound confusing, but the name of the variable itself is name. And to call this function, now I can remove this my thing from here. And while calling, now there can be a couple of ways. You can either pass things directly like this, or you can go and put something inside a variable. Let's say s equals to cd, and I pass s over here, or the result can be coming from maybe another function itself. For example, let's say I write something like, and once I run this code, it gives me another list attribute has nothing called as join. So okay, my bad. It should be written something like this: string, the string with which I join, and inside the bracket I need to pass the list, and this print something like this. So you can call this function in different ways, and this function expects one argument. What happens if you don't pass an argument? It's going to give you an error like function requires one argument, but there is no argument that's given. Cool. Also, you'll notice there's something called as positional argument, which Python is telling us about, and it's saying that it requires one positional argument, but we haven't given it. So if you ever see this kind of error while running your code, it means that you're passing less or maybe more values than expected. For example, if I write something like this, it gives that it takes one argument, but I'm passing it to. So these kind of things are there when you are calling function. So you can call it with lesser or more number of arguments, but it may give you some kind of exception that, and it will tell you what kind of arguments it expects. Another important thing to notice over here in Python, there is no notion of the data type or the type that you specify or you can specify for the arguments that you're putting over here. So Python doesn't allow, I should not say allow, it can allow. For example, I can say str. So once I do this thing, I'm saying that name should be of type string, but Python doesn't enforce or do any kind of specific type checks over here. And so I can even write something like this and it would just work out. The only reason this thing is working is because I'm not doing any kind of string specific operations over here. For example, if I do something like name dot upper, now upper is a function which can only be invoked on strings. So all these examples would work out because I'm passing strings over here. But the last example, which is this, won't work out. Why? Because integers don't have an upper function, and you will see an error like int object has no attribute or function upper, something like that. Cool. So you can see that the previous calls succeeded and they printed the names in capital, but the last one fails and it says int object has no attribute upper. So that's something to remember. So why does Python provide this? This is something called as type hints, and Python doesn't itself check about type hints. It doesn't validate anything. But what can be done is you can run tools which are outside of Python, or I should say, which are built for these specific things, and they can, you once you run those tools, they are going to give you errors or warnings about these kind of issues where you expect something to be a string versus you're passing an integer. That's possible, but that's outside the scope of functions. But just for the sake of clarity, so this is not something which is checked by Python directly at the runtime, or even when it is interpreting or reading your code before starting the execution. It can be, instead, these kind of checks can be enforced via some external tools which are beyond the scope of functions. All right. So this is the basic syntax of a function. So you can define functions which take one argument, two argument, more than one, two arguments, n number of arguments, and even there are things like variable number of arguments. Now let's come back to our original problem, which was to convert this to a function. One important thing to realize or to understand over here is functions are kind of uh, uh, you can functions are kind of box you can consider where you give the input and you get the output. So functions get the input in the form of arguments, which we have already seen. For example, this function takes input in the form of name. Some functions may not take, that's rarely the case, but that does happen as well. For example, this print my name function doesn't take anything because it always does the same job. You also notice that we have already been using a lot of built-in functions. For example, print is itself a function, and you can call it with one argument, with no arguments, with n number of arguments. There are a lot of options. Similarly, there are other functions in Python. For example, dir, we have been using it a lot. And what dir does is it tells you about what all things are available. If you call it without any argument, it gives you a list of names or variables or things which are defined in the current scope, and stuff like that. So there are a lot of built-in functions as well, and we have been using that already. Specifically, the print function, we have been using it a lot. All right. Now let's take this code and let's rewrite in another way. So this piece of code, I want to convert it in the form of a function. And so what I'll do is I'll just say def, let's say my underscore POW. So I'm going to find the x raised to the power y or b raised to the power e. And I'm going to say, let's say x comma y column. And I'm going to put this logic inside this thing. And instead of saying in range e, I'm going to say y, because I'm finding x raised to the power y, and the multiplication should be done with x. Now I'll just print this result at the end, and this should do my job. And I should place this function above this thing. That's not exactly necessary over here, but I just want to show that first we define the function and then we are going to call it with the input taken from user. Now I say my underscore POW bracket, let's say b comma e. And one important thing to notice is that the variable names that you use over here and these variable names that you put over here, they have no relation. They're completely independent of each other. I'll show you with another example about that, but just remember that they have no relation. So they can be same, they can be different. It's up to you what you want to use. So I'm using it like this, and if I run this code and I'm asked for input, and it gives me the correct output. I can even run my code without taking input or with hard-coded values, my underscore POW bracket, let's say 3 comma 4, and once I do this, it prints me the output as 81. All right. So this is another example of a function which takes two arguments, and I should say it returns nothing. We'll talk about return types or return type of a function, or not return type, functions returning value soon. Now, one more important concept I'll show you over here, which I just talked about, that there's no relation between this and these variable names, is something like this. Let's say I define a function f which has a variable which takes a variable x. Say I say print x, and then I say, or I should put a marker here, from function, say this, and I print x, and I want to make a slight modification, x equal to 20, and then I say from function, say after, and then I'm going to call or use a variable with the same name x, which is 10. I'm going to call this function f with this variable x, and then I'm going to say print after function, and I'm going to print the value of x. So if I run this code, what's going to happen is I create a variable x, which I should introduce a new term over here, which is in the global scope. And as soon as I call this function with this x gets copied over here, or this x which is present over here, it's a new variable, or it's a different variable. So this x has function scope, or it's not in the global scope, I should say. And this x and this x both are actually different. Now, when I come over here, the value that this x refers to is 10 right now. All right, because I passed x over here, which actually points to 10. Now, when I say print from function, it's going to print 10. Then I make x equal to 20. So the x which is present over here gets or converted to 20. And then when I say from function after, it should print 20 over here. Once this function finishes, I will come back to line number 7. So there's nothing else left to do after the function call is complete. And then I'll execute line number 8. And since this x and this x were different, so the x which I modified got wiped out immediately as the function exited, and the x which is being used over here is still the global one. So if I run this thing, you get this output 10, 20, 10 instead of 10, 20, 20, which you might have expected. And I think I have made it pretty clear why that's happening, because the scope or the light or the time for which this, or the place at which this x is visible or it is created or available, is just this function. It's not available outside of this function. All right. And that's the reason why you can use same or different variable names and it doesn't matter at all. Cool. So the next thing over here, we are going to talk about the return value of a function. Let's put that in title. Let's see some examples. Let's see some examples of functions which we have been using already. Let's take example of dir. Let's say I create a variable and I say dir. And if I check print type of, if I check the type of this thing, it says that it belongs to the type class list. And that's corrected, because if you see print r, it's going to print out a list of strings, because these things are enclosed in quotes. So it's essentially a list of strings. So always in Python, every function returns a value. All right. But have you ever tried to see what does print return? Let's try to do that. Let's say r equal to print. So the job of print is to print something. It doesn't do any kind of computation or calculation, or it doesn't generate any kind of result. Its job is to just print something or put out something on screen. All right. So when I say r equal to print, it's going to print something. But now let's inspect what is the value present inside r. So I'll say type of r, and what's inside r. Let's see. So print returns a special thing called as none, and the type of none is none type. That's the only kind of object of none type available, which is just none. It's booleans have two kind of values, which is true and false, but none type has only one value, which is none, and none denotes empty or nothing. So a lot of times functions don't have anything to return, or they don't do any kind of computation which needs to be returned as a result. In those cases, those such functions return a none value, and none denotes nothing or empty or something like that. All none in all null in other programming languages. Cool. So how does that happen? Let's look at the functions that we have defined earlier. So I had defined my POW. This doesn't return anything. And even the function before that, which is print my name, doesn't return anything. So let's do one thing. Let's define a function. Let's say def func, and let's just put a pass over there. So pass is used to just complete the syntax, because if I want to define a function which doesn't do anything, and if I just run the code, it's going to say EOF error. What does that mean is Python is expecting that after you put the colon, after you have started the definition of a function, there should be at least one statement after it with indentation. And since that's not there, so it's giving us an unexpected EOF error. Once I put the pass, so pass is a keyword, it just tells like, we don't want to write any code. It's like a no OP, no operations, and it doesn't give me any kind of errors over here. Now, if I call this function, let's say r equal to funct, and I say print r, it's going to print me a none. The reason is by default, all functions return a none value in Python. Cool. So if you don't return anything from a function, it's going to give you back the result as none. And if would try to print the result of this thing, it's going to be none. That's for sure. Now let's come to the example where we might want to actually return something. Let's take this code and use another keyword called as return. Let's say return 10. Now if I run this code, it's going to return the value which I have written over here, and it would be 10. Cool. So that's the idea. And return is a keyword which has two things, or which does two things. So return can be used inside functions only. Second thing is, actually that's just a description of return. So the first thing now would be, you can have 0 to n return statements inside a function. For example, this function has 0 return statements, this function has 1, but you can have more than 1 as well. And the other important thing is, as soon as the return statement is executed, your function exits. Let me show you that with an example. So let's consider there's a function def funct, and I say over here, let's say it takes a number, and it's going to check if n modulus 3 is equal to 0 and n modulus 5 is equal to 0. I'm going to say, or I'm going to return a value fizz buzz. And if n modulus 3 is equal to 0, I'm going to say return fizz. And if it is divisible by 5, I'm going to say buzz, and otherwise I'm going to not return anything. So this function has all these statements as part of it, even though there are blank lines, but it doesn't mean that the function finishes in line number 4. It's still continuing. Why? Because the next lines of code are still indented at the same level. So now if I go and put a statement over here, let's say r equal to funct with a value of 4, and then I say print r. So first it's going to check, it's going to go, so how does the function call execute, or how does your code execute? It starts from top to bottom. So when Python would read your code, it would see that you're defining a function. So it's going to load all the statements, check for syntax errors, and call it or put it under the name called as funct. All right, and it's not going to execute them. Then it would come to line number 10, it's empty. Then it would come to 11, which says r equal to funct. So this is actually something which can be executed. When it starts executing, it will look up for this function name. Since we have already defined it, it will be able to find it. Once it finds it, it will start executing the code. And while executing, so the value or the arguments that we have given, they will get copied into n. So 4 goes over here. Is 4 modulus 3 equal to 0? No. So we don't need to evaluate. Second one, 4 modulus 3 equal to 0? No. 4 modulus 5 is equal to 0? No. So we don't return anything over here, and by default the function returns 1. This is the expected outcome of this thing. If I go and say print funct bracket 3, now it should print fizz. If I go and say print funct bracket, let's say 30, which is divisible by 4, so it should give us fizz buzz. And if I do something which is just divisible by 5, it would give me a buzz. So this is a simple example with multiple return statements. And if you would notice, for the example of 30, when I ran this thing, so as soon as it evaluated that this condition is true and I executed this return statement, it didn't go further. Because if it would have gone further, 30 is also divisible by 3, then it might have returned fizz also. But then this 30 is also divisible by 5, so it could have returned buzz also. But since as soon as return is executed, your function exits, hence we never go down to the other if statements. They are never even checked at all. So a return statement exits or stops your function, and whatever is returned after it gets returned from the function. So that's something about your return statement. So now coming back to our original problem, which was like finding the power. Now, let's say I want to write something like this. I want to use the result or the result that's generated by the calculation of 3 raised to the power 4 into some other computation. Let's say I want to add 10 to it, and after that, I want to print the result. Let's say r equal to this thing, and then let's say print r. If I run this code, it's not going to work right now. The reason is because this function doesn't return the result. It just prints it on the screen. We don't want to print the result. We want to use it in some other computation. So since this function doesn't return anything, it's going to return you a none, and you cannot add none to 10. So if I run this, you're going to get an error, unsupported operand plus for none and int. That's expected. So how do I fix this? So I just say return, let's say res. Now what happens is whatever is computed by this function, it's going to get returned over here. And since it's an integer or a number, it can be added to 10 and you get this output, which seems to be correct. 81 plus 10 gives you 91. So typically when we are writing function or when we define functions, the best practice is that your functions should never rely or they should never directly take input from user and they should never give the output as well. Instead, what they should do is they should take whatever they need for doing the operation as an argument, and they should return the result if there is any. And that's the ideal way, or that's the best way of writing functions. Your function should never do the input output. Instead, if you specifically want to do some special kind of input or output, you should put them in separate functions or maybe do it directly and then just pass the outcome of those into the function. That should be the best way, because writing code like this allows me to do things like this as well. So I can write something like POW, my POW, let's say 2 raised to the power 4 raised to the power 4. So what it's going to do is it's going to first compute my power with the value of 2 to the power 4, which is what's going to give you 16, and then 16 raised to the power 4, which is going to give you probably 256. Let's give it a shot. No, it's giving you much larger value, my bad. But anyways, this is the idea. So you can nest these kind of function calls, because the return value of this thing can directly be passed to another my POW or maybe to some other operation as well, like how we are doing it over here. So that's the way you should ideally define a function, and this is some basic idea of functions, how to define function, what's the best way of defining them. And again, functions are about code reusability. Once you have defined them, you can reuse this function anywhere at not anywhere exactly, it depends on how you define or where you define the function. You can reuse this function. That's the idea. Sometimes the intent behind defining a function is not exactly reusability. It's more from a perspective like you want to modularize your code, or you want to break down your code into more readable, organizable chunks, so that it's very easy for you to understand what's happening in a piece of code. So that's also another intention. It's not always reusability. Sometimes it's just for the sake of clarity, or you want to break down your code into smaller, manageable, understandable chunks so that it becomes easier at a later point. So that's it about functions, and the notebook for this thing is available on the GitHub repository over here. Please check that out and feel free to comment and ask for any kind of inputs. Cool. Thank you.